Hi, mathletes. Today we're going to explore dependent and independent probability. If you roll a number cube and then flip a coin, would one affect the other? And it would not. So we'd say that they're independent because what you roll doesn't change how the coin is going to land. In this video, we'll be asking the question, does one event affect another? That's the key to figuring out if it's dependent or independent probability. For an independent event or mutually exclusive, we would say that one event does not affect the outcome of another. Here's some examples. That rolling the number cube and flipping a coin, or picking a card and then putting it back and picking again. If it's a dependent event, it does affect the next. So it's the opposite of independent. Here are a couple of examples. If you pick a card, but this time you keep it and then you pick again, that means there's one less to choose from. Or you take one marble out of a bag and you don't replace it before you pick again out of that same bag. So let's decide if each pair of events is dependent or independent. So you're going to choose two socks from a drawer without looking. That's going to be dependent because the first sock changes what's left because you're not replacing that sock. You're going to roll a number cube and then you're going to pick a card from a deck. And that's independent. One does not affect the other. What about if you take a cookie from a cookie jar, you eat it, and then you pick another? And that's definitely dependent because there's one fewer cookie to choose from. And the last one, you're going to flip two different coins. And that's independent. They don't affect each other. Now remember that independent does not mean random. It means it's not affected by something else. Order does not determine if it's dependent. It's whether one event changes the outcome of another. These are some common misconceptions. Replacing an item keeps the events independent. Drawing two cards without replacing the first is dependent. And drawing one marble from one bag and then one marble from a totally different bag would be independent. So what's the probability of flipping heads and rolling a 4 on a 6-sided number cube? Well, we know that that's independent because the flipping of the coin is not going to affect what I roll on my number cube. So to figure it out, we could do something called a tree diagram, which is going to have these branches. And we're going to have our first event, which is the flipping of the coin, then our second event, which is the number cube. We'll figure out the outcome, and then we'll calculate the probability. So for the first event is the coin, and the second event is the die, or the number cube. So for the first event, I could flip my coin and I could get a head or I could get a tail. The probability of getting a head is 1/2, and the probability of getting a tail is also 1/2. Now I have my second event, which is rolling the cube. The probability of me getting a 4 on my number cube is going to be 1 out of 6. So I can get a 4 or not a 4. So again, the probability of getting a 4 is 1 out of 6. The probability of not getting a 4 means I would get a 1, 2, a 3, a 5, or a 6, or 5 out of 6. Now, if I get my tail, the probability of me getting, I could get a 4, or I could get a not a 4. And the same thing, the probability of getting a 4 is 1/6, and not a 4 is 5/6. Now let's look at the outcomes. So for the first one, I could get a head, or I could get a 4. The second one, I could get a head or not a 4. I could get a tail and a 4, or a tail and not a 4. So now we're going to figure out the probabilities. The probability is going to be 1/2. Here's my 1/2 multiplied by my 1/6, which equals 1/12. Now for the next one, I have my head, which is 1/2. The probability of not a 4, which is 5/6, which equals 5/12. For the tail and a 4, the probability of getting a tail is 1/2. A 4 is 1/6, so 1/12. A tail is 1/2. Not a 4 is 5/6, so 5/12. So what I wanted was I wanted to get a head, and I wanted to get a 4. So a head and a 4. So I multiplied my 1/2 and my 1/6, and I ended up with 1/12. So the probability of flipping a head and a 4 is 1/12. Now, when we make these tree diagrams, we can make sure that we haven't made an error. If we add up all of our probabilities, they should equal 1. So the sum should always equal 1 because one of these things has to happen. Now let's try another one. And in this one, I have a bag with 4 green marbles and 6 yellow marbles. And I want to know what the probability of picking 2 green marbles would be without replacing them. So this is now going to be dependent, but I still can make my tree diagram. Our first event, second event, outcome, and probability. So the first event, well, I want to get a green marble. And the second event, I want to get another green marble. Okay, so what's the probability? Well, what can I get for my first event? I could get a green or I could get a yellow. What's the probability of me getting a green? Well, there's 4 green and there's a total of, let's see, 4 plus 6 is 10. So I have 4 tenths. The probability of yellow? Well, 6 are yellow, so 6 tenths. Now, the next one I want to get is I want to get another green. Okay, so now I have to take this one away. So I had 10. I took one away because I already chose one. So how many left are green? Well, let's see. I could get a green or a yellow, but now there's only 3 that are green because I took one away. And there's also only 9 marbles, so I have 3 nines. How many yellow? Well, there's still 6 yellows, but there's only 9 marbles left. Now, I could get, if I picked my yellow first, I could also get a green or a yellow. And again, there's 3 ninths for the green and 6 ninths for the yellow. So now we can do our outcomes. I could get a green green, a green yellow, a yellow green, or a yellow yellow. And the probability of getting a green green, I'm going to multiply my 4 tenths by my 3 ninths, and I end up with 12 90ths, or I can simplify it to 2 15ths. For the next one, I have my green and yellow. So my 4 tenths multiplied by my 6 ninths, and that's going to equal 24 90ths or 4 15ths. I'm going to continue on with my yellow green. So to get a yellow is 6 tenths multiplied by my 3 ninths, and I end up with 1/5. And then lastly, my 6 tenths multiplied by my 6 ninths, and I end up with 2/5. So let's see. The probability of picking 2 green marbles is going to be 4 tenths multiplied by my 3 ninths or 2 15ths. And again, if I add these all up, they should add up to 1. It might be easier to add them up when they have the common denominator here. Now, is there another way to calculate the probability without having to try to draw that tree diagram? Because that took me some time to do. Well, let's look at flipping heads and rolling a 4 on a 6-sided number cube that we did before. Now, with our tree diagram, we found that the probability was 1/12. And then we also did the one with the bag without replacing, and we found out that the probability of getting 2 green marbles was 2 15ths. Well, what do you see, and what do you think, and what do you wonder? Look at these equations and see if you can come up with some ideas. You might want to pause the video here. Well, in mathematics, we can calculate the probability of independent events. And we can do that by using a formula, which is the probability of A and B. And we write the probability of A and B as the probability of A multiplied by the probability of B. So let's try it on the one where we flipped the heads and we rolled a 4 on a 6-sided number cube. So we'd say, what's the probability of getting A? And A is the one with the coin. Well, the probability of flipping a head and 4, well, a head is 1/2. And the probability of rolling a 4, well, that's 1/6. So we multiply 1/2 and 1/6, and say the probability is 1/12. Wow, that was a lot faster than making my tree. But what about dependent events? Will it work for that too? Well, let's see, the probability of A and B, but this is the probability of A multiplied by the probability of B given A. In other words, after A has happened. So let's try that again. We're not replacing because it's dependent. So the probability of A, let's see, the probability of A is that I get a green marble. And we said that that was 4 out of 10 multiplied by, but I took one of my marbles away. So now instead of having 4 green, I only have 3 green. And I have one less marble total. So I have 3 ninths. See, I took it away. So I only have 3. And then if you count those up, I have 9. So 3 ninths. And the product of that is 12 90ths, which we can simplify to 2 15ths. Kind of a lot quicker than using that tree. But I like the tree too because it's very visual. So let's use our equations for these situations. So what's the probability of rolling a 6 on 2 number cubes? Well, we know that's independent. One doesn't affect the other. So we're going to say the probability of A multiplied by the probability of B. So 1/6 multiplied by 1/6. So the probability is 1/36. Well, what's the probability of drawing an ace and then a king? I'm not replacing it though. So in this case, it's dependent. For this, you need to know a little bit about decks of cards. And for this one, for an ace, there are 4 aces in a deck of cards. And a deck of cards has 52 cards in it. So we'd say 4 out of 52. For a king, there's also 4 kings, but I took the ace out. So how many cards are there? If you said 51, you're correct because I took 1 card away. So the product of the numerators and denominators, whoa, that's a big one. And we can simplify it to 4 out of 663, which doesn't look so simple to me, but it does tell me that that is not very probable. That means out of 663 times, I only get it 4. So what if you put the marble back before you drew it again? Okay, so with that marble one, how is that going to change the probability? Well, now it makes it independent because instead of having one less color or one less marble, it now stays the same for each one of the draws. But what if there were more blue marbles than red? Well, the probability of drawing blue increases, which affects outcomes in dependent cases, especially without the replacement. So could one event that seems dependent be made independent? Yes, what you could do is just replace the item or reset the conditions between the events. So here's a quick recap of independent versus dependent probability. Remember, independent events or mutually exclusive events, one event does not affect the other. The outcome stays the same no matter what happens before, and our formula is you multiply the probability of A and you multiply the probability of B. For dependent events, one event does affect the other, and the outcome of the first event changes the chances for the second. The formula, multiply the probability of A and multiply by the probability of B after A happens. So remember, replacing items usually keeps events independent, and not replacing items makes them dependent. Ask yourself, does the first event change anything about the second? I hope that helps with clarifying the difference between independent and dependent probability. And you have 2 different ways of calculating that by making a tree diagram or using the formula. As always, thank you for watching. And if you like this video, check out some of my others.